Welcome to the lecture series on deep reinforcement learning. One of the most exciting developments during the last 10 or 15 years has been the success of reinforcement learning in games such as chess or Go. In these games, the output, the action, such as moving a piece, is represented as a neural network which takes in a representation of the input, and the neural network has parameters, and these parameters determine which actions are most likely to be taken for a given input. One output per actions, and the weights, the parameters of the neural networks are optimized by playing against itself. Now, there are two important methods in reinforcement learning. The first one is TD learning. The second one is policy gradient. And importantly, for this lecture today, the two can also be combined. And this gives rise to actor-critic networks. All methods based on TD learning use either Q values or V values. What are Q values? Q values are the expected total reward that you can collect starting on this branch here, starting in state S with action A1. And the rewards could be at the first step or at the next step or further down in the graph. You accumulated all these rewards starting in a state action pair. Something very similar are the V values, but that's the total expected discounted reward that you can collect starting in a given state S. Now we want to model these V values or Q values using a neural network with parameters. The parameters are W. How would you optimize these parameters? We use a loss function, and the loss function expresses the consistency condition, for example, between the Q values up here and the Q values down there. And we use gradient descent, but a method that's called semi-gradient because we only take the gradient with respect to the state Q of SA and not with respect to the parameters of the next state S prime. And something very analogous happens for V values. We have a loss function which expresses the consistency between V values up here and V values one level down in the graph. The aims of today are to understand the principles of deep reinforcement learning in artificial neural networks, and we will combine methods of TD learning with methods of policy gradient, which gives rise to actor-critic networks.